Here's A, and here's B. Draw the free body diagram of the two cylinders together. And we'll put a little X, Y, X, Y. So draw a free body diagram of those two bodies, and they have to be cylinders, and we'll talk about why in a minute. You can't draw them as dots. Daniel G. I think we're up to you. Ben gets skipped. What forces should I draw here? We already drew them all here. We just have to figure out which one of these are, which ones are all here.
Well, you could draw a force going down.
Which ones? Label them.
NAB.
Let's skip that one for now.
Okay.
Let's do the easy ones first.
Well, you could
So what forces are on these two cylinders together?
weight.
The weights. Good. That's always the easiest one. Always say weights first, then you feel good. And we know these, right? Okay, what else? Hector.
The normals
Which ones?
of the surface. So NA.
Right, good. NA. And I'm going to just draw it like this for now, just because for me, I like to get the physical feel. And I'm totally fine. You could draw it up here if you want. But for me, I always think of it as a push, as a compression. And what's the angle here? 30. And here is, you definitely didn't draw it to scale, huh? Okay, so now, trying to think of Gonzalo. Okay, Gonzalo, what's going on with the NAB? So let me ask it another way. When originally we start with these two cylinders touching each other, right?
Yeah.
And when I remove them from each other, right? When I remove them from each other, this realizes that that guy was touching him, right? And this guy feels like this guy's touching him, right? So when they're removed, those forces, you have to put them here because we can calculate them. They become external forces. But when they're together, what's happening here? A is touching B, B is touching A. They're both putting equal and opposite loads on each other. So when I draw the free body diagram of those two together, do I draw an NAB?
No.
Yeah, good. You do not draw NAB because they're equal and opposite. Just think of it. Taking this physically, taking this free body diagram and combining it with this free body diagram, what happens? The NABs drop out. Right? And it's the same thing. So it's not until you separate things that you get to put that force, because then it becomes an external force. Right now, it's as if they're welded together. Okay? So here we have 1 and 2 unknowns. Does everybody understand this? This is really, really important, and you're going to be doing it all the time. And we did it on Tuesday. Right? On Tuesday, we did this problem, where we had the cable. We drew a free body diagram of 1, we drew a free body diagram of 2 separately, and we had a tension in A. But when we drew a free body diagram of link 1 with the cable there and B, there was no tension because it was internal. It's only when you separate it that it becomes external. Because look at this problem. Right now, while this, is everybody with me? Everybody with me? This cylinder is touching this plane right here, right? This surface. There is no normal. Well, there is a normal, but they're equal and opposite. There's an NA from the floor to the cylinder, and there's an NA from the cylinder to the floor, which is part of its weight. Okay? It's not until I take the cylinder away from its surface and away from the other cylinder that I actually can draw these normals. It's a really important concept. Charlie?
So when you have two moving bodies that are touching, then
Two moving.
two bodies that can move that are
Okay,
touching.
so
can
everything
you
has the
ignore-
ability, everything has the ability to move, right? But we're making sure, we're designing it so it doesn't move, right? Like failures in engineering, when we design machines or, I mean, in machines there are moving parts, but there are parts that you don't want to move. If they move, it broke and flew, right? Okay, Charlie?
So if there's two parts that you can move apart from each other,
Yes,
then you're going to ignore the normals that's
that's between them,
between them.
correct.
You just consider the normal of the surface and the body. That's it.
So when you, ask the question again.
I think I got lost there.
Okay, okay. When you have a body, once you separate it from something, that's when you could draw the forces external.
Okay.
And that works both for tension and normal?
Works for everything. So if we go back to our problem that we did the other day, we had a cylinder that was suspended from the ceiling. Right now, when it's connected to the ceiling, there's an equal and opposite tension. There's a tension here that's I kind of draw it a little weird because I don't want to go into that right now, but you always draw it away and away. The cylinder is pulling this tension and the wall in essence is pulling this. The tension is there. It's not until I break that and I don't have it connected to the ceiling that I can actually draw the tension as an external. Because right now, there is an internal, two internal tensions that are canceling each other out. Okay, so do I only have two unknowns in this picture? There's another unknown there, what is it? The angle. This is an unknown too. And so is that. Right? So the sum total, what's the total number of unknowns I have? 4, right? Because I don't know the direction of NAB. In this free body diagram, I have 3 unknowns, and this free body diagram, I have 3. Everybody good? Okay, so now let's do a full statics problem. You ready for a full one? And I don't remember if this is in the packet or not. So it's not too complicated. The reason I always want to have the problems so you have them in the packet is so that you don't have to redraw them, but this is a quick one. So why don't you just take a moment to draw it.